This video is the first of the series of videos on the rise of solar cells. In this video, we will discuss the initial days of solar cells, the challenges that led to the slowdown in solar research, and the need for industry-scale adoption of solar energy. In 2009, the price for generating 1 megawatt hour of electricity from a solar power plant was $359. 10 years later, this decreased to $40, an 89% improvement in price. The electricity from onshore winds improved by 70%, while that from nuclear became worse by 26%. Non-renewable energy like gas improved by 32%, while coal remained the same. The electricity generation from solar energy improved the most over the last decade, making it the most affordable source, with the prices expected to continue the trend in the future. Solar module prices follow a similar pattern. From 2009 to 2019, the price for solar cell modules decreased from $2.8 to almost 20 cents per watt, a tenth of what it used to be a few years ago. Looking back to the 1970s, the solar module prices have come a long way, from being over $100 per watt to as low as 20 cents, improving by a huge 99%. This means more investments in the solar sector, more solar power plants, creating more solar jobs, efficient solar modules, lower production costs, and the cycle continues. Solar photovoltaic cells are the main reasons behind the rise of the solar energy industry, and most likely, these cells will be the leading source of electricity generation in the future. Generating electricity from sunlight was first observed in 1839. The electric current was produced when two plates of platinum or gold immersed in acidic or alkaline solution were exposed to sunlight. Next, in 1876, a group of scientists discovered that selenium could turn light into electricity without heat. Based on this, the first solar cell was created using selenium in 1883, and the first commercial solar water heater was patented 10 years later. From the late 19th to the early 20th century, scientists conducted various experiments and published new theories, including the Nobel Prize winning law of photoelectric effect by Albert Einstein. With time, the semiconductor industry shifted to integrated circuits built on silicon, which allowed the creation of the first silicon photovoltaic cell in 1954. Silicon photovoltaic cells managed to generate enough electricity to power electrical equipments. Hence, for the first time, solar cells were used to power Vanguard satellite alongside its primary batteries. Before moving to the next part, if you like this video, please press the like button and subscribe to the channel to get more videos on global energy developments. From the 1960s to the 1990s, solar cells were mostly used by the space market. Since these markets involved customers with high budgets, they could afford the higher costs of solar cells. High-paying customers meant there were no efforts into improving efficiency and bringing down costs. This made the solar technology very niche, meaning investors were unwilling to invest money into the research and development of solar technology and make it commercially viable, which in turn led to very limited production and hence the high costs. This resulted in a slow period in the solar cell research. The slowdown in solar cell research was for another reason: easy access to cheap fuel that was economically more viable to countries than investing in a new technology that had an unclear future. Coal and gas became the common source of energy supplies for most countries, and renewables were far from any consideration. With time, the demand for fossil fuels increased, and more countries increased their dependence on oil exporting countries, particularly the Middle East. This gave oil producers a strong control over global politics. In the 1973 and 1979 oil crisis, high prices of oil in the US and parts of the Europe affected the global economy, and a need for energy independence was realized. At that time, the global crude oil demand was 3 billion tons. At such an alarming rate of consumption, fossil fuels depletion became a strong concern, and its consequences when we run out of it. Topics like global warming, Arctic melting, and climate change took over the media. This gave a strong push for a sustainable energy source that is carbon neutral and economical to deploy in large numbers. Investing in research on renewable energy became a necessity, and many countries joined in active renewable energy research. This led to formation of intergovernmental organizations for cooperation in knowledge sharing and adoption of renewable energy. And with this, we complete the first part. In the next video, we will discuss how the oil crisis and the shift to silicon wafers in the semiconductor industry helped in the large-scale production of solar cells. Please subscribe the channel to be informed about the upcoming videos on global energy developments, and click the like button if you liked this video.